Hello, friends. Excited to spend a little bit of time with you today. Wanted to give another try at recording a video to work through the counting change problem. And so I'm going to do this a little bit differently today. Hopefully I'll have time to get this done. Might get interrupted, but we'll give it a try just the same. Okay, so I want to share screen 4 with you. Here we go. This is what the problem looks like. I love problems like this because the description is very elegant. Develop a program that selects a total charge and then a total payment that exceeds that charge. Have the program calculate the change. Bonus points to anybody who can count back change. Okay, so I was a cashier for about 3 years of my life, and this is a problem that makes a lot of sense to me. And if anybody's ever had to go out and buy anything, this hopefully will make sense to you. And so I kind of look at it as we're going to have 4 general pieces. The first part, figure out how much the bill is. The second part is figure out how much the customer gave you. Third part is figure out what the change is supposed to be. And then the fourth part is going to be counting the change back. So let's go ahead and let's just copy. We'll just copy this to get started. Okay, I am feeling not adventurous, and so I'm going to do this inside of Eclipse. I'm going to make a new class inside my exam2, and I'm going to call this making a change as cashier. I'm going to include a public static void main. I'm going to go ahead and finish. Okay, so hopefully this is legible enough to everybody. It does run, and so let's go ahead and get this fired up. Right, because if you can't push it up to the cloud, it's probably not worth saving. And so that all looks good. And away we go. Okay, let's drop in our description right quick. Oh, my bad. And what I'm going to do is I'm going to stop this right there. And then I'm going to do this. I've been lecturing a lot, and that's never a good idea. Okay, so there's 4 main parts. And so we know this works. I'm going to go ahead and get rid of this clutter right here. I'm going to say double charge equals guess get random charge. Okay, now it says this doesn't exist, and I'm okay with that. Now, what I'm going to do next is I'm going to do double payment equals get random payment. Okay, and then I'm going to do, I'll do double. And I'm going to do this as an array. And I'm going to say double change, no, money back. Money back money, how about money denominations equals new. You know what? It helps if you can spell these things. Today has not been my day on that. And so here we're going to go with, I'm going to have a 20. I'm going to have a $10 bill. I'm going to have a $5 bill. I'm going to have a $2 bill because they're awesome. A $1 bill, a 50-cent piece. I'm going to have a quarter. I'm going to have a dime. I'm going to have a nickel. And I'm going to have a penny. Okay, so those are my money denominations. And I'm going to say, I'm going to have an integer, and I'm going to keep track of number to give back, which is going to be a new int array. Helps if you actually do it right. And this is going to be the size of money donations dot length, right? Because basically, for every denomination, we're going to need to have something that we're going to need to give back. Okay, so this is going to get a little bit ugly, but we're going to come in here and we're going to say, let's do calculate the change. And I'm going to pass in this, the charge, the payment, money denominations, and number to give back. Right? Now, the thing that I want to point out is that money denominations and number to give back are both arrays. And so arrays are objects, and what that means is it's going to be, once it's created, it stores its information. Anything we do to it inside the method is going to exist as it occurs to the object because it's passed by reference, not by value. Okay, and then last but not least, we're going to have count change back, and we're actually going to say pass it the exact same parameter set. Okay, so we've got these 4 custom methods. Eclipse always creates them on the top, and I want to do them sequentially. So I'm just going to come in and I'm going to create them one at a time. And this way, okay, so how much is the charge? Well, get a random charge, and that gives us this here. And then it says get random payment. Well, that's next part. And so the top kind of reads like a story, and then you can see how the story unfolds down on the bottom. All right, let's save it. Make sure that we haven't bricked anything yet. And we see that life is all pretty good. We don't have any print statements yet. So let's go add in some print statements. Okay, and we shouldn't have anything here yet, right? It doesn't have anything. So let's go ahead and go down here and let's fix that. So we don't need the to do. Actually, I'm going to do this a little bit stupid. Okay, so let's just, it's a double, so let's do math.random. Run that. Okay, so that's not very cool. Let's, because it's like less than $1. Let's keep it in a range, $100. Okay, so that's 37 bucks. That's nearly $100. Cool. Now it's still doing something stupid, right? And it's got all those funny little numbers on the end. So let's round those off just a little bit so we don't have like 63.06 cents, which doesn't exist. We'll do math.round of this little guy, right? And let's see what that looks like. Well, now we're only getting whole dollars, and we need those cents back. So this is a little trick that I picked up off the internet, and I'm just going to do this right quick. So the idea is we're going to take everything in here and multiply it by 100, and then we're going to round it. And then after we're done rounding, then we'll divide it by 100. And so let's see what this looks like now. $85.74, 78.34. Cool. All right, so that is the sum total of our code that we need to do, which is get our random change. Now, you'd say, Everett, why are you such an idiot? That's one line of code. Why didn't you just drop this in up here? Well, it's because I'm extremely lazy. And now what we're going to do is I'm going to steal this. And I'm going to come down here. And now we get our payment, right? And I'm going to say double charge. Well, no, that doesn't work. I need to know what the charge is as part of this. So we're going to add that. And why we do this is going to make sense here in just a second. And I'll say, I'm going to say while payment is less than or equal to, well, while it's less than charge. Because if they're the same, it's easy. And I just grab this. Now I should say while payment is greater than or equal to charge. So as long as we've got enough money on the table to cover it, no. I was right. If payment's less than the charge, we need to get a different payment amount. And then when we're done, we'll just return what the payment is, right? So let's say, say that our charge is $5. We drop in and we say, let's get a random payment, $1. Is $1 less than $5? Yes. Okay. All right. Roll payment again. Okay. Now we roll the payment again. It's $100. Is $100 less than charge? No. Okay. Skip out of the while loop. All right. Should be good to go, but I don't trust it. So when I don't trust it, I use a print statement. Okay. Cool. So the total charge was $48.19. The total payment received was $71.25. 70 some odd dollars is more than 40 some odd dollars. I am well pleased. Okay, well, I'm paranoid, so bear with me. Have a total charge and payment rated for cashier. And so commit and push, we'll get this pushed up, right? So we've got those two little things. And notice it's not a real nasty code. You know, hopefully you feel like it's pretty straightforward. Okay, so now we're creating two data structures, two arrays, money denominations. Again, we've got 20s, 10s, 5s, 2s, 1s, 50-cent pieces, 25-cent pieces, dimes, nickels, and pennies. Cool, this is what they called for. All right, now we're going to calculate the change. This is the part that was slowing me down just a little bit this morning. And so I'm going to go in here and I don't have to return anything, which is nice. So the first thing I'm going to do is double and I'm going to say money back equals, and this is going to be payment minus charge. And you know what? Yeah, we'll leave this in here. That's fine. And then I'm going to break my own rules because this is Let's just run that. And let's see if the numbers line up. Okay, is 5 plus 2 is going to be 7. I like that. 7 plus 8 is going to be 15. Carry the 1. 1 plus 3 is going to be 4. Plus 2 is going to get us 6. And then 2 plus 3 is 1. And I like all of that. So I think we've got the thing working the right way now. Okay. So now we've got this little thing that we have called money back. And it's going to just be our own little process here. Okay, so I'm going to say, actually, let's do the 20s first. So I'm going to say if money back greater than, and this is going to be money denominations of 0. So if it's bigger than this, then we need to say, all right, so we need to do, we do number to give back of 0 plus equals 1. Actually, we'll just do plus plus. Plus plus. So that should just take whatever's in there and increase it by 1. And then I'll say money back equals money back minus denominations of 0. Okay, semicolon. Okay. All right. So let's just run that and see if I've bricked anything. So that's interesting. Now it's doing this little action again. And so we probably need to go up and do a similar process here to what we've done before. And so I'll just drop this in here and see if we can preserve this and get it to do what I would like it to do. Okay, so let's save that. Let's run it. Okay, 8 plus 7 is going to be 15. Carry the 1. 6 plus 8 is going to be 14. Carry the 1. 6 plus 8 is going to be 14. Carry the 1. And 3 plus 1 plus 1 is 5. Cool. Now we've got that working again. All right. Well, this worked for the first case. Let's do it for the rest of them. So I'm going to say for int denomination index equals 0. And I'm having a bad day typing, so I'll just copy this. Denomination index less than money denominations dot length. And I'm going to wrap that just to keep it tidy. And then grab this. Plus plus. Drop that there. Okay, Let's just see if I've bricked anything. All right, so I feel like this is probably doing something pretty cool. But I honest to goodness have no idea. And I also, like, I know that print statement tells me that I'm getting the money back thing calculated correctly. I know I want to probably print off what I'm actually getting back. And probably I would do that on line 50 or 51. So I'll do that for now, just for my own sanity's sake. So and oh, we need to control A, control I this. And by the way, denomination index goes in wherever we've got a 0. And then I'll say all right, so hopefully we can start to see this working now with the little print statements. All right, so that's obviously a problem. And we know how to fix that problem. So the nice 2 little parentheses up front, and this all at the end where this used to be. Save it, run it. And see if that fixes that. Maybe not. Oh, that was weird. Let's run this again. And let's just see if we can go up and take a look at it. Okay, so this is our sanity. So the total charge was $45.68. You need to give back $22.14. Yes, because 12 cents would take this up to $46, plus another 2 cents to make it $46.02, which is what this is. And then 46 plus 22 is going to be 68. Okay. So this part is working well. You need to give back another 20. Agreed. $2.14. You need to give back another $2 bill. Cool. So that drops us down to 14 cents. You need to give back another dime. So that drops us down to 4 cents. Oh. That's not an if. That needs to be a while. Let's try this as a while, my friends. Okay, let's look at that. So 19, you give back another 10, so down to $9. Give back another 5, you're down to $2. Give back another 2, down to 2. $2 down to 21 cents. Okay, a dime, that, another dime to 1 cent. Give back another cent, you get down to 0. Booyah! We got it. Okay, so I'm glad we did that. That helped me suss out those logic errors, but I am going to go ahead and comment these out now. and let's run it without comments. Okay, and now, because I'm paranoid, let's do change all those. And let's push that up. Okay, I like that. I like that quite a lot. Okay, now we need to do counting the change back. And I'm going into this with a lot of confidence because I just saw that it was working. Okay, this one takes a little bit more work or a little different mindset. So this is how you count change back. You're going to say, and this is where you drop in what the payment was, right? And now we can, so let's run that. You gave me $92.81. And can I do a dollar sign? Cool. Let's go tidy these up just a little bit. Well, that looks pretty. And oops. Okay, now we can come down here and work on this. It says you gave me, and now I'll do a \T. Whoops. Let's do another \T. And I think I'm going to need 2 of them, so I'm just going to do that right away. You gave me $89.54. I'm going to go with 3 again. 3 indentions. Whoops. Silliness. Sweet. The total is $40.62. Okay. 4. And then I'm going to do this. I'm just going to grab this whole thing, right, and get us started on our for loop. But I'm going to change this a little bit. I'm going to grab this, cut it out. No, I said this part. Thank you. And I'm going to start in here. I'm going to say -1. I'm going to say greater than or equal to 0. I'm going to say minus. Okay, drop that in. AI, save, it runs. Okay, now we can pop in here and say, do plus, I'll do a dollar sign, plus, and I'm going to do, this time I'm going to do number to give back of denomination index plus, or no, times our denomination I'm going to do a while loop again. I'm going to do this while loop. I'm going to say while 0 is less than and I want you to do this, right? So what we're going to do is we're going to give back our coins one at a time. Okay, so it's not happy about, oh, I see. All right. So what we need to say here is, so we're going to say do. I'm still thinking this through just a little bit. I'm going to say double working total. There we go. Working total equals charge. I'm gonna grab this and I'm gonna paste it in here. I'm gonna copy this and right there. Okay. I'm gonna cut this and I'm gonna say number to give back of denomination index minus minus. I'm going to say working total equals working total plus any denomination of the index. I'll just come in here. I'll say makes working total. Okay, so let's just crank on that. Uh-oh, I made an error. You know what? You got to put the semicolons in. Java likes those. Okay. So let's do a \t there and see if that lines up. Something's not right, and I get that. But I'm gonna slowly get there until I get my brain. Ah, okay. That's fun. So we need to come up here and do our trick again. So it is, where's math.round? Grab the payment 2 out front. Come down here to working total. And then math.round, and it's the 2 afterwards. And so we just replace the semicolon. Save that, see if that fixes my issue. Weird. Okay. So you gave me $99.20. The total was $95.97 plus a quarter makes 96.22, plus $1 makes 97.22, and a $2 makes 99.22. That worked really cool, and that makes sense. Now let's look and see if this makes sense. You gave me $82.17. The total was $71.42. I think I need to drop a T in there. Let's see if this throws everything off. Nope. Okay. So $28.99 plus a penny makes $29, plus another penny makes 29. No, another plus a dime makes 10, 20, 45, and a half dollar makes 95. Okay, so now we're up to $29.95. I get $1 to get up to 30, $2 to make 32, and then $5 to make 37. Cool. Now we go plus 20 to 57. So awesome. It is working, and this is working well. So I'm going to go ahead and get that pushed up. And let's take a look at this again, right quick, just to kind of take a look and see what everything is doing. I'm gonna usually, yeah, change to another spelling typos. I apologize. Not having a great day on the spelling. I'll be honest there. And I'm going to add a couple more. Print statements just for funsies. These are not important. Thank you and have a nice day. Cool. And then I should probably be a good kid and change all those print LNs to print Fs and format the printing to print it out. I'm not feeling it right now. So let's talk about this again. You get a total, you get a payment, and then you calculate the change. So this is the total, this is the payment, then we calculate how much to give back of each, and then we calculate the change, and then we count the change back. And then I just have a nice little sign off here. Okay, so how do we get the total? Fairly straightforward. We just said, okay, I want it to be somewhere between here and $100. To round it off to get the change, we multiplied everything by 100 and then rounded it and then divided by 100 to shift the decimal place back. Okay, how did we get the payment? Well, we said, hey, whatever the charge is, get a payment. If the payment we guessed that time is less than the charge, run it again and just keep doing it until we get a big enough one. So maybe it runs once, maybe it runs 1,000 times. I still don't care. Okay, so we've got the total, we've got that. Now we're going to bop down and we're going to calculate how much to give back. So here's what this looks like. It said we need to give back however much money we need to give back. And so what we're going to do is we're going to look at each denomination. We're going to start at the large denominations and go down to the small ones. So while the money back is greater than the current denomination we're working with, like if we've got $40 to give back, if that's bigger than $20, we're going to give another 20. So you increase the number you're going to give it back, and then you also then you just tell and then you update how much money you have left to give back after you give one back. Okay, then after we calculate all of those, so we do that, as long as we've got a penny to give back, we give back another penny. As long as we have another 5 to give back, we give back another 5. And so there's actually no repeats on that last one. Let's see if I can get one that does have a repeat. Yeah, so this one, give one dime to make 27, then another dime to make 37. So that's why that while loop is here. Okay, now we're going to count the change back. This is the last part. And this time we go in the opposite direction. We start with the little coins. So pennies didn't have any of those. Nickels didn't have any of those. Here's a dime to get from 86.17 to 27 and then up to 37. Drop a quarter on top of that to get to 62. And that's where we need to be on the cents. 86.62 plus a dollar makes 87, and plus a 5 spot makes 92. All right, friends, this was a lot of fun for me. This went a lot better than the one that I did this morning because I had another chance to look at it and to think about it a little bit. We got that all done in less than 100 lines of code. I'll go ahead and get this posted up and get this tidied up. But if anybody, stop my share right quick. Hey, if anybody needs anything, let me know. Had a lot of fun with this algorithm. It's just a process of doing things. It's a concept that lays out an idea. So this is the idea of how do you calculate change and how do you count changebacks when you've got a fixed number of things that you have to do. And one of the other cool things is the way that I set up the algorithm. I started with the largest numbers, and so it was technically a greedy algorithm. So how many 20s can I get rid of? That took care of getting rid of as many 20s as we could. That's the biggest hole you can fill with the 20s. Then you go to the smaller hole, which is the 10s, and then down to the 2s, and then the 1s, and then the half dollars and quarters and dimes, so forth. If you have any questions, let me know. If you're having fun, let me know. Look forward to hearing from all of you in the discussion. Thank you all for your time. Have a wonderful day.